So the holding cost has addressed the cost on the time dimension for this one-to-one system. Now let's work on the spatial dimension, which is transportation cost. So when we mention the transportation cost, let's refer to the transportation by truck. So if you want to dispatch a truck to send something, typically it's related to several factors. First factor is the distance. Okay, in our case, let's assume the distance between location A to location B. Let's say the distance is D. So in the holding cost analysis, we focus on the travel time between A and B, which is TM. And now in the transportation cost analysis, we will focus on its physical distance or travel distance, which is D. And also, the cost relates to how many items you will ship every time. So we need to know how many items you shipped. Definitely, every time you want to dispatch a truck, there will be some fixed cost associated with that. For example, if you ask a truck to load or unload your stuff, it all costs time or money. So in general, we have these factors. In our model, we will focus on two parts. The first part is the fixed cost, and then the second part is the variable cost. So first, let's focus on the fixed cost. So when you order a truck, there will be some certain stopping cost, like load or unload cost. Let's denote this type of cost by CS, or sometimes this S, we call it stopping cost. So every time you ask a truck to send something, there's a stopping cost. And then there is a fixed cost related to the travel distance you want to ship. So this term, we call it mileage cost. Let's use CD to represent it. So this cost is the unit mileage cost. Then the total cost should times the distance. Let's see, this is a mileage cost. So the fixed cost will be the summation of these two terms. Now let's talk about the variable cost. So the variable cost is relatively simple. So every time it relates to how many items you send for each truck. So let's see, if you assume the load for the truck is V, then your variable cost, unit variable cost, let's say unit variable cost is CV dollar per item. Okay, then you can have your total variable cost is equal to CV times V. So let's recall our small triangles. Remember, this is our production rate or consumption rate D prime. This is our headway. This is our load. Okay, so remember our transportation costs are calculated based on sending the truck each time it incurs a fixed cost. So this is our fixed cost. And also we have a variable cost. So let's see, for 1 year, let's see how many dispatches we have. Remember, the headway is H. So let's see, if we assume the headway is given by year, unit of the headway is year, then the number of dispatches will be 1 over H. So in this case, we will generate a fixed cost for the entire year times the number of dispatches. This is the total fixed cost. So let's see the variable cost. Every dispatch we have the load is HD prime. So we have the variable cost this is for one dispatch. Then we calculate how many dispatches over a year. Okay, so this is a fixed cost. This is a variable cost. So remember that this is a total cost for 1 year. Now let's try to calculate the prorated cost per item. Remember the entire number of products is D prime for 1 year. So we can just divide the number of products D prime by this cost. So in this case, if we calculate the cost for each item, okay, so remember the total number of products is D prime. So the fixed cost, we need to divide it by D prime. And then the variable cost, we also need to divide it by D prime. And also H is cancelled. So we just have CV, which is intuitive. So in this end, we can have the total transportation cost per item equals fixed cost and the variable cost.